Welcome back to another video from Lord Gizmo. With nothing but a stack of wood sheets and sheer determination, one man is about to lay the foundation for a full-size yacht. A build at a scale most people would never attempt alone. These sheets serve as the base structure on which a mold made of layers of composite materials will be built and solidified. But cutting them to exact dimensions and fitting them together with precision, that takes a truly skilled pair of hands. The joints are smoothed down, and wax is applied as a mold release agent, ensuring the finished hull can later be separated cleanly. This primer also seeps into the grain of the wood, filling every last texture and leaving behind a perfectly smooth surface to build on. He then lays a sheet of fiberglass over the surface and works epoxy resin into it. This combination is remarkably effective. Once cured, it forms a tough, reliable structure that can handle both heavy loads and the harsh conditions a boat faces on the water. From here, he builds upward, adding fiberglass panels along the sides to form the walls of the hull. Trimming off the excess wall is an important step. It gives the boat the clean, proportioned form it needs, both to look right and to perform well on the water. He bonds rows of half-cut plastic pipes along the walls, locking them in place with epoxy and fiberglass. A simple but clever technique that distributes stress evenly and keeps the walls from flexing under pressure. Once that's done, he runs a long, thin pipe along the top edge of the walls to mark the correct trim line. Cutting the walls to a consistent height ensures the hull is level and symmetrical, which is fundamental to how the boat sits and performs on the water. Using a jack, he carefully flips the entire hull upside down to work on the exterior. With the hull flipped, he can now peel away the thin boards from the bottom. Their job is done, having served as the mold for the hull's shape. He runs an orbital sander across the entire hull, smoothing out any rough patches left behind. He then paints the hull a deep dark red. Hull paint isn't just cosmetic. It's a practical choice that resists marine growth, conceals grease and grime, and serves as a visual reference for other vessels during navigation. He deliberately leaves the underside of the stern open at this stage because this section gets its own dedicated build. He constructs a separate mold that will form the tunnel hull, a recessed cavity beneath the stern designed to house the propeller shaft and its surrounding pipes. Building it independently allows him to dial in the exact shape and fit before it becomes a permanent part of the hull. It is pretty much the same process. Wood sheets are cut and joined together, wax is applied as a mold release, and then it's painted. Once the mold is in place, fiberglass and epoxy go over it, locking that precise curved form into a solid, durable structure. The tunnel hull keeps the propeller fully submerged and positioned at the correct depth, which is essential for maintaining thrust and fuel efficiency. It also acts as a protective shell, shielding the propeller from underwater debris and impact with shallow surfaces. He installs several mounting bolts into the stern section. These will anchor it firmly to the rest of the boat structure once the two pieces come together. Several holes are drilled through it to route the pipes, and mounting clips are installed inside to hold those pipes firmly in position. He has to test the fit carefully against the existing hull to make sure everything lines up correctly. Once every component is properly placed, the hollow area within the structure gets filled and sealed with a top cover, making it one solid unit. Next, he refines the surface, sanding it down smooth before painting it to match the rest of the hull. While the paint dries, he flips the hull back right side up and elevates it off the ground. He then brings the tunnel hull section into position and joins it to the stern deck. Steel plates are mounted at precise intervals to maintain a consistent gap between the two sections. This ensures both parts sit perfectly level and aligned before being permanently locked together. Threaded steel pipes pass through both sections and are fastened with nuts, pulling everything into a single rigid assembly. This method distributes the connection load evenly across the joint, preventing any single point from cracking or shifting under the stress of open water. At this stage, the boat is still nothing more than a hollow fiberglass shell. And a hollow shell alone cannot handle the demands of open water. He begins the reinforcement process by running long wooden planks along the gunnels, the upper edges of the hull walls. To lock them firmly in place, he drills bolts that pass straight through the wooden plank and into the fiberglass wall, with another plank fastened on the opposite side. Essentially sandwiching the fiberglass wall between two planks with a single bolt running through all three. Once everything is tight, he trims off the excess bolt ends for a clean, flush finish. This clamping method significantly increases the structural rigidity of the entire hull. The top face of the gunnel is then covered by laying precisely cut planks across it, secured with nails into the wood already in place beneath. With the gunnel fully covered, he runs a sander across the entire wood surface, smoothing it down into a clean finish that looks like it was built that way from the start. Next, he installs a series of wooden crossbeams spanning the full width of the hull interior, each one bolted firmly into the walls on both sides. These beams form the skeleton that will eventually support the deck floor above. Metal handles are also mounted along both sides of the gunnel, giving anyone on board a secure grip when the water gets rough. Attention then shifts to the stern, where he welds a steel pipe into the tunnel hull. This is the upper section of the propeller shaft housing. The point where the shaft enters the boat and connects to the drivetrain below. Getting this weld right is critical, as this joint has to withstand the constant torque from the engine and the heavy vibration that travels back up through the spinning propeller shaft. A sturdy mounting frame is then built from a combination of wood and iron, engineered specifically to hold both the engine and gearbox in a fixed, aligned position inside the hull. If you're enjoying this build, make sure to like, subscribe, and share. It really helps the channel grow. And we'd also encourage you to check out the Nasatchannel. He's a true boat lover, and his channel is packed with builds just like this one. Nasat also knows his way around a lathe. He machines a custom shaft from scratch to connect the propeller directly to the gearbox. This kind of build also demands a great deal of welding work. And it's the kind of job where safety gear isn't optional. Proper precautions matter every step of the way. Once it's properly greased, the shaft is finally slotted into place. Next, the propeller is installed onto the end of the shaft, completing the drivetrain. He then fabricates a bearing joint that serves as the coupler between the propeller shaft and the gearbox. the critical link that transfers rotational power from the engine all the way down to the propeller. He fits a flanged universal joint coupling onto the gearbox output, bolting it securely in place so it can transfer power while still allowing for slight angular flex between the gearbox and the shaft. The gearbox goes in first, seated and secured onto the frame, followed by the engine, which is positioned and aligned directly behind it. Both units are then welded to the mounting frame, eliminating any movement or shift, because even a small amount of play between the engine and gearbox under full throttle can cause serious mechanical damage over time. Before lowering the engine into its final position, he also fits rubber dampeners underneath. These absorb engine vibration and prevent that constant shaking from transferring directly into the hull. The rubber element sits between the two metal flanges. Without it, that constant hammering would crack the gearbox housing or chew through the gears over time. It also compensates for very slight misalignment between the engine and gearbox shafts, which is nearly impossible to eliminate completely in a hand-built installation. A seacock strainer is also installed in the hull. A perforated metal screen that sits flush against the bottom of the boat, allowing seawater to enter the cooling system while blocking debris, weeds, and anything else that could clog or damage the engine's water pump. He doesn't buy one off the shelf. He machines it himself on a lathe, turning and drilling the metal to precise dimensions so it fits the hull opening perfectly and seats with a watertight seal. To make the seacock strainer running, he installed the water pump and connected it with the engine so it can drive power. Next, he builds another metal frame, but this time to install a circulant cooler near above the engine. All the pipes are connected coming from the water pump and the engine to this cooler. He fabricates a series of pipes to route the engine's exhaust safely out of the boat. Without a proper exhaust system, toxic fumes would have nowhere to go. If you're still with us, that says it all. You genuinely love these kinds of builds. So make sure to hit subscribe so you don't miss the next one. This is another coupler, and this one will change the powerhouse of this build. A 13 kilowatt three-phase electric motor goes in alongside the diesel engine, and he wires it into the gearbox through that same drive coupling. This setup lets the motor and engine work as a team, rather than two separate systems. The electric motor can turn the propeller on its own for quiet, low-speed cruising. Then the diesel engine takes over once more power is needed for speed or longer distances. When the engine runs, that same motor switches roles and acts as a generator, topping up the onboard batteries so there's always power ready for the next stretch of electric-only running. This setup costs far less to operate day to day, since the diesel engine only fires up when it's actually needed. He constructs a new flange, one that couples not just with the propeller shaft, but also with the electric motor. Finally, he connects the motor to the rest of the drive system. And to run it properly, it requires a three-phase motor control setup to manage its power and speed. The engine fires up and runs smoothly, a solid sign that everything underneath has been put together the right way. The build is now entering its final phase. He installs a metal sheet at the front of the boat, securing it with bolts that run straight through into the boat's interior structure. Reinforcement that matters here more than anywhere else, since the bow takes the hardest hits from waves and impacts, and this extra layer of strength helps prevent cracking or wear over time. He frames out the top cover structure of the boat, closing in what was previously open above. The sealed liquid cans visible inside the crossbeams are placed there deliberately. They trap air and act as built-in buoyancy chambers, keeping the boat afloat even if water finds its way into the hull. The inner wall surfaces are then covered with fiberglass, sealing and protecting the interior from moisture and structural wear. After the seating is in place, he coats the entire boat first with a layer of primer. Then finishes it with a bold blue top coat. Bright, eye-catching colors on boats serve a very practical purpose. Unlike roads or runways, open water has no painted lanes or traffic signals. So a vessel's visibility depends almost entirely on how well it stands out against the water, both to other boats and to Coast Guard or rescue teams in an emergency. A gray rubber mat is laid across the open deck floor. pressed flat and carefully tucked against every edge. It adds grip underfoot and gives the interior a far cleaner look than bare fiberglass, especially when the deck gets wet out on the water. Attention then shifts to the electrical side of the build. He routes and connects the relevant wiring to both the engine throttle lever and the gear shift lever, the two controls that give the operator full command over the boat's speed and direction from a single position. A pressure gauge is mounted right next to other controls, placing it within the operator's direct line of sight, so any drop in pressure can be spotted immediately. Often the earliest warning sign of trouble brewing in the engine. This compact gearbox sits at the heart of the steering system, taking the rotation from the wheel and redirecting it 90 degrees down toward the rudder. A classic stainless steel ship's wheel is now mounted on the deck. A steel-reinforced rubber hose guides the steering line, keeping it protected and properly aligned as it runs along the deck to the rudder. And here comes the rudder. Once installed, it will translate every turn of the wheel into a real change of direction on the water. With the seat fitted into place, the yacht is finally ready to hit the water. Let's see how it performs. But first, you can take a closer look at the final build. So what do you think of this build? Let us know in the comments below. And one more thing, if you're a boat lover, go follow the Nasatchannel. And don't forget to like, share, and subscribe. We'll see you next time.